Welcome all. We continue with our epidemiology module, and today's talk for the discussion is a likelihood ratio. Likelihood ratio is a continuation of your screening test only. Okay. So in the screening test, what we have seen up till now was the sensitivity, specificity, positive predictive value, negative predictive value. We have seen. Now we will learn two separate concepts: positive likelihood ratio, that is LR positive, and negative likelihood ratio, that is LR negative. Okay, so these are the two concepts which are different from the positive predictive value and which are different from the negative predictive value. I did not combine this with that because otherwise you will get confused. Okay, so positive likelihood ratio is different than the positive predictive value. Negative likelihood ratio, LR negative, is different from the negative predictive value. Okay, so if the test is positive, how much more likely is the disease? So that is what is the positive likelihood ratio. Okay, so it is, if the test is positive, how much more likely is the disease? And the formula for the likelihood ratio positive is sensitivity upon 1 minus specificity. Okay, so suppose you have the test sensitivity as a 90%, you have got the specificity as 80%, then likelihood ratio positive will be sensitivity upon 1 minus specificity. Okay, sensitivity upon 1 minus specificity will give you the likelihood ratio. Here the sensitivity is 90%, specificity is 80%. So likelihood ratio positive is 0.9 divided by 1 minus 0.8. Okay, 0.9 divided by 0.2, that is 4.5. So interpretation is a positive test is 4.5 times more likely in a diseased person than the healthy person. Okay, this is what is the meaning of likelihood ratio positive. A positive test is 4.5 times more likely in a diseased person than the healthy person. Okay, so what exactly LR is suggesting? Likelihood ratio positive wants high sensitivity and high specificity because large numerator and small denominator. Okay, so large likelihood ratio positive is good likelihood ratio positive. If it is more than 10, it suggests strong evidence for the disease. So if the likelihood ratio positive is more than 10, there is a strong evidence for the disease. Okay, now we will talk about negative likelihood ratio. If the test is negative, how much does the disease becomes less likely? So when the test is negative, how much does disease becomes less likely? So as a clinician, what is going to be my impression when I get the negative test? Okay, because we are looking at the patient and we are performing the test, we have got a certain assumption before we get the test result that this patient is likely to have the positive result or negative result. Some assumption is there. How much that changes after the result when it is negative? So if the test is negative, how much does the disease becomes less likely in the patient? So LR negative equal to 1 minus sensitivity upon specificity. Always remember, sensitivity is in the numerator and specificity is in the denominator. Here it was a sensitivity upon 1 minus specificity. Here 1 minus sensitivity upon specificity. These are the only two formulas which we have to remember. Okay. So here it was a sensitivity upon 1 minus specificity is the likelihood ratio positive. Now likelihood ratio negative will be 1 minus sensitivity divided by specificity. That is the difference. And these are the only two formulas which we have to remember when we talk about the likelihood ratio positive and likelihood ratio negative. Likelihood ratio negative equal to 1 minus sensitivity upon specificity. Always sensitivity up and specificity below. In likelihood ratio positive, you have sensitivity divided by 1 minus specificity, and in likelihood ratio negative, you have 1 minus sensitivity divided by specificity. If the test sensitivity is 90%, specificity is 80%, then likelihood ratio negative is 1 minus 0.9 divided by 0.8, that is 0.1 divided by 0.8. So likelihood ratio negative is 0.125. So interpretation is a negative test greatly reduces the chance of the disease. Okay. So good likelihood ratio, if the likelihood ratio is less than 0.1, it is very good. Okay, there is a strong evidence against the disease. Okay, suppose screening test for the Down syndrome. Here the sensitivity is 95%, specificity is 90%. So likelihood ratio positive will be sensitivity upon 1 minus specificity. So 95.95 divided by 1 minus 0.9. So 0.95 divided by 0.1 equal to 9.5. So a positive result strongly suggests the disease. So this is what is my impression as a clinician, that a positive test is telling about the evidence. 9.5%, 9.5 is a high likely the patient is having the disease. Now negative result, likelihood ratio negative, that is 1 minus sensitivity upon specificity, that is 1 minus 0.05, that is 0.05 divided by 0.9 equal to 0.056. A negative result almost rules out the disease. Okay, so same thing we are going to discuss now. Sensitivity, specificity, positive predictive value, negative predictive value, LR positive and LR negative. So sensitivity, if the disease is present, how often is the test positive? Okay. If the disease is present, how often is the test positive? Specificity, if the disease is absent, how often is the test negative? That is what is the specificity. Positive predictive value, if the test is positive, what is the probability of the disease? If the test is positive, what is the probability of the disease is the positive predictive value. Then if the test is negative, what is the probability of no disease? That is the negative predictive value. Okay. Now likelihood ratio positive. If the test is positive, how much more likely is the disease? How much more likely is the disease? If the test is positive, how much more likely is the disease? Is the LR positive? And if the test is negative, how much less likely is the disease? It is the LR negative. Okay. So that is what is the comparison of all this. So these are the formulas which we have learned. Sensitivity formula we have seen, that is true positive divided by true positive plus false negative. It should be high to detect the disease. Specificity, that is true negative divided by true negative plus false positive. Ideal value should be high to exclude the to say that the disease person is healthy. Okay. Then LR positive, likelihood ratio positive, is sensitivity upon 1 minus specificity. Ideally, the value should be more than 10 to rule in the disease. And likelihood ratio negative is 1 minus sensitivity upon specificity. Ideal value is less than 0.1 to rule out the disease. So positive predictive value, negative predictive value will tell about the probability after the test. Okay. So PPV and NPV are the probability after the test, while likelihood ratio and likelihood ratio positive and negative will change in the probability after the test. Okay. Change in the probability. It is the change in the probability. This is talking about the probability, but this is talking about the change in the probability after the test. Okay. So predictive values give a probability, answer what is the chance, and we have positive predictive value and negative predictive value, and they depend on the prevalence. Remember this one thing you have to remember, these predictive values depend on the prevalence, while likelihood ratios give strength of evidence, answer how much should I change my belief. Once you get the positive result or negative result, how much should I change my belief as a clinician? And that is possible with the likelihood ratio positive and likelihood ratio negative, and it is independent of prevalence. Okay. So for example, we have few SBAs now. We'll try to solve the SBAs with the help of formulas which we have learned. So Dr. Sansi, you want to go ahead now?
Yes, sir.
Yeah.
A new screening test for preeclampsia has sensitivity of 90% and specificity of 95%. What is the positive likelihood ratio of this test?
Positive likelihood
So,
ratio is what is the formula?
sensitivity divided by 1 minus specificity, sir.
So sensitivity here it is a 0.9. Okay.
Hmm.
So 0.9 divided by 1
1
minus
minus 0.95.
0.95. Okay. 1 minus
Hmm.
0.95 is a 0.05. Okay.
0.05,
So
yes, sir.
0.9 divided by 0.05. Okay.
Hmm. Yes.
So
100.
0.9 divided by
18.
0.05 is will be 18. Okay.
Hmm.
0.9 divided by 0.05 is 18. Okay, what is the interpretation? Likelihood ratio positive of 18 means that a positive test result is 18 times more likely in a woman with preeclampsia than in a woman without preeclampsia. Okay, so that is pertinent to. So LR positive more than 10 provides strong evidence to rule out in disease, to rule in disease. Okay, because it is a more than 10. Okay, next example, go ahead.
A diagnostic test for fetal growth restriction has sensitivity of 95% and specificity of 80%. What is the negative likelihood ratio?
Formula for the likelihood ratio negative.
1 minus sensitivity divided by specificity.
Yeah, that is 1 minus 0.95.
0.95. 0.05 divided by 0.8.
Yes. So
5,
0.05 divided by
8. 5 and 5 2 7.
0.8. Okay. So it will come 0.06. Okay. 1 minus
0.06.
sensitivity divided by specificity. Okay. 0.065. So what is the value? It is too low, no? Less than 0.1 it has come. So interpretation, a negative result substantially reduces the likelihood of fetal IUGR. LR negative less than 0.1 provides strong evidence to rule out the disease. Okay. So that finishes the today's topic of likelihood ratio positive as well as likelihood ratio negative. Thank you.